Okay, well, we've got about 40 attendees. There's still a few people joining, but we'll make a start. Hello again, everyone. Good afternoon. My name's Charlie Law. I'm your host for the next hour or so at this PEFC Timber and Carbon CPD webinar. Just to give you a little bit of background on myself, I've worked in the industry for probably nearly 40 years now. Most of that time was at one of the principal contractors, a company called Band Construct UK, but I've spent probably the last 12, 13 years um, working in as a freelance consultant for many different organisations, including PEFC, Timber Development UK, and other contractors. So today we're here to talk about timber and carbon. Just a few housekeeping bits. If we just look at that. If you've got any questions, if you put them in the chat, and I'll try and pick some of them up as we go along if we can. If not, we'll pick them up at the end. So just click on that. You should be muted, but if not, just keep yourselves on mute if you don't mind. We are being recorded. Your questions and stuff won't be shared. So if you've got any questions, they don't appear on the recording. So please feel free to send stuff through. Okay. Just a bit of an outline on what we're going to be doing today. So we're going to, why measure carbon, carbon-related impacts for timber, and the importance of responsible sourcing when timber sourcing when you're looking at carbon. We're going to be looking at EPDs and whole life building assessments, how you take account of timber within those. We'll look at how you might be able to reduce that carbon by looking at circular economy aspects, and then we'll touch at the end on some of the stuff that the timber industry is doing for our net zero roadmap and other information to try and hit net zero targets by 2050. So that's the outline to today. And hopefully by the end of that, you'll have a much better understanding of all those points. And we will be issuing you with a CPD certificate at the end. So hopefully everyone's happy with that. So why do we need to measure carbon? Well, I think we've all sort of started to see these lines coming in. The global temperatures over the last 100 or so years. And you can see there that generally our temperatures were there or thereabouts. Some years slightly colder than others, some on par with what they are normal temperatures, which is the white. But you can see that over the last 20 years, since the turn of the millennium, our years have been getting steadily hotter. And we are now starting to hit that 1.5 degrees that we wanted to try and keep. We've got a number of targets in place. The Paris Agreement we mentioned there was to limit global warming to well below 2 degrees and preferably to 1.5 on pre-industrial levels. But as we said, we're probably hitting that 1.5 degrees near enough now. In the UK, we've obviously taken that on board and set our own legal targets to reach net zero by 2050. That was set in June 2019. And we've got an interim target to reach 81% reduction by 2035 compared to 1990 levels. And that was announced by the government at COP29 in November 2024. Part of, the reduction in carbon is also part of the UK government's timber and construction roadmap. I actually chair the working group that's looking at that. And that's looking at the built environment obviously counts for around 25% of the UK's annual greenhouse gas emissions. So by increasing the use of timber and stuff like that, which sequestered carbon, it's hoped that we can significantly reduce the emissions to help achieve the 2050 targets while still stimulating the economic growth. That's straight out of the roadmap. So that's the sort of thing we're looking at, and we are, a lot of the stuff we're going to be covering today feeds into that net zero roadmap. But this goes back even further. You've got things like the Letty Climate Emergency Design Guide, Pour and Desai, saying that we now know that unless we change course drastically within a lifetime of people alive today, we are heading for a world which can support only half to a billion people. Now we're obviously a lot more than that, probably near 8 billion people now. So we really need to be doing something. This is a climate emergency that we need to look at. And there's a lot of stuff around government as well. Government Climate Change Committee, which sort of advise governments its carbon plans. That also states that we should be developing plans to rapidly scale up levels of wood used in construction and support the assessment and benchmarking of whole life carbon in buildings. And that's key where we're coming from today. And that sort of ties in with what we're looking at with Part Z, which is an industry initiative proposed to the government to say, look, we really want you to start measuring the whole life carbon in buildings. Because we feel that is one way that we can help reach your net zero targets. So Part Z isn't law or legislation at the moment. It's purely a proposal by industry, but it's getting a lot of traction. Again, that's one of the proposals in the net zero road. The timber and construction roadmap is to consult on that. Supposedly by the end of last year, and that hasn't happened yet, which is a shame. Just to give some background into the costs of this. This is an analysis done by built by Nature Study. And you can see there that actually the analysis of a lot of the carbon timber buildings that have been erected in certain parts of Europe show significant reductions in CO2 when optimizing that building design to minimize embodied carbon. So not all of these are timber; they're just been optimized for to optimize that embodied carbon element. But you can see there that generally they are cost neutral or favourable cost impacts. So the blue line there is the cost. You can see there that some of those were significantly lower costs than a standard building at the same time, if not cost neutral. None on this list were actually above that cost. So timber and carbon. Just going back, I know this might take you to suck eggs and going back to your old biology lessons, but timber, trees, sequester and absorb CO2 out the atmosphere. They emit the oxygen element and they store the carbon element as the timber in the timber fibers. So that's what makes up a lot of your timber. So 50% of the dry mass of a piece of softwood is biogenic carbon. So the actual half the mass of the timber is biogenic carbon. So 1 cubic meter of softwood. This is from the average across all the weighted average across all the timber that's in the UK. Stores on average around 751 kilograms of CO2. And that CO2 stays locked in that product for forever until it either decomposes or is burnt. The only time that the CO2 releases if it decomposes or is burnt in biomass. Even when you're recycling that timber, so if you recycle a piece of timber into, say, some chipboard, the carbon still remains locked within those fibers within the chipboard. So, that carbon can stay stored in that timber element if we recycle it and reuse those elements forever. And unless we burn it, and that's why we need to start looking at maybe reducing how much of that timber we burn. And even where we do burn it, a lot of the work going on at the moment around biogenic carbon capture and storage, CCS or carbon capture, storage and use, is trying to see how we can capture a lot of that carbon out of the atmosphere. So by the time the timber going into the buildings now is maybe coming out and may get burnt, I'd be very hopeful that actually that CO2 doesn't actually end up in the atmosphere. It stays locked away somewhere, whether that's in a number of different ways that they're looking at the moment. Just going back to that timber and construction roadmap. So, what the one of the things the UK government is looking to do is increase planting to try and sequester more of that carbon out of the atmosphere within the UK. And when you look at how much carbon is actually stored, this is the European stocks that we've got here. The European forests are storing over sort of 120, 130 billion tons of CO2 in the forests, and that's whether that's in the soil, whether that's in the woody biomass, but also in the harvested wood products, which is that light and green line on the top there. Is about 40 million tons stored each year in the harvested wood that you put into buildings. For the UK, slightly different figures. There's still a lot stored. Obviously, we've got a lot less forest cover in the UK. We're maybe down to 13%, whereas European average is over 30, 37. But we're still storing sort of 4.5 billion tons of CO2 in our small amount of forest that we've got in the UK. And obviously, because we're still using quite a bit of timber, we're storing quite a bit of that timber in that in the harvested wood products. That light green line at the top is quite thick in the UK because we still use a lot of timber buildings. So we estimate it's probably over 400 million tons of CO2 stored in the timber buildings at the moment, according to the Forestry Commission. So just how do we assess that? How do we measure that carbon? How do we know it's there? Well, there's a few, obviously, lots of scientific studies have gone over the years, and these have been put into a number of standards. So two key ones are the BSCN 15804 and 15978, which is the measuring carbon in buildings and measuring carbon in the products. You've also got ISO 14025, which is the international standard. The EN standard is a European standard, and like I say, the 15978 is interpreted in the UK by the RSCS whole life carbon assessment for the built environment. So when you're measuring carbon in a building, we should be looking at that RSCS product. If you're measuring carbon in a product, you're more likely to probably be looking in Europe in that EN 15804. And there's obviously other documents behind that that relate to timber and how we measure certain elements of that. Now, the way carbon is accounted for, both in products, but particularly in buildings. If we look at a building example here, the way a tree, the timber works, the tree grows, and a piece of softwood, typical piece of softwood coming from Europe or the UK on average, might be around 50 years old. So if we go back 50 years, that tree has been sequestering carbon out of the atmosphere over that 50-year period. So by the time it's felled and used in a building, and we say year zero there, that has sequestered that 750 kilograms of CO2. Now, there's obviously an upfront impact where we're processing the timber, harvesting it, transporting it to the sawmill, etc. So there's obviously a figure there that reduces that amount by a certain amount. So it might be sort of 50. So probably around 50 kilograms of CO2 in that upfront impact. So the remainder there, so you're looking at around 700 kilograms of carbon still stored in that piece of timber for the duration of that piece of timber. And the standards generally, there's a couple of ways of looking at it. There's an alternative view where we should be saying, well, we should take that carbon over the life, at year zero, and discounting it over the life of the building by about 50 years. And I can understand why some people are saying that, because we need to try and make sure the building stays up for as long as possible. But when we look at pure accounting terms, there is this missing carbon gap, because the carbon has been taken out of the atmosphere. But if you're not accounting it for 50 years, there is a gap in that carbon accounting. So the standards don't look at it that way. The standards very much look at it in the same way as the backwards looking approach, where they take that carbon at year zero, allowing for the upfront. But what they do is they set a limit of 60 years. So after that 60 years, you need to take account of the timber coming out of the building and the impacts of that. And because you've taken account of the sequestered carbon up front, you need to add that back in at end of life. So that's why you end up adding back in that 750 kilograms of carbon plus a little bit more for the for transporting off-site, demolition, processing, etc. But during that time, you've got that stored carbon. But if we do keep that in the building, like I say, we've set that the standards have set it at 60 years. But if you can keep that timber in that building for 100, 120 years, 150 years, 200 years, there's a door in Westminster Abbey that's 1,000 years old. If we can keep that in there, that's locking that carbon up forever. So that's just how the standards approach it. One of the key things in the standards is it talks about responsible sourcing of timber. So in 15804, definition of sustainably managed forest is key, and it says sustainably managed and certified forests are any forests which are operating under an established certification schemes for sustainable forest management. So examples we would include in that would be FSC, PEFC, obviously, UPFRont, which is the UK Woodland Assurance Standard, grown in Britain as well. It gets picked up within that sustainably managed forest. You can also include non-native forests or short-term forests which are managed. So that's things like the UK Forestry Standard would pick that up. and some other areas there which don't really apply to the UK anyway. The two main ones there are the top two, but the main one being, let's say, things like PEFC certification would allow you to take account of the sequestered carbon up front. If you don't have that guarantee that that timber has come from a sustainable source, you won't be able to include that sequestered carbon up front, but you still have to include the impact of end of life, which means that timber building would be very carbon inefficient. Obviously, the reason that they're asking for this is that there have been issues in the past and still are of deforestation in certain parts of the world. So, yeah, these are the latest figures from the UN Food and Agriculture Organization up to 2020. Hopefully, they generally do these on every 5 years, so we should see some data sometime this year going up to 2025. But you can see there that we were really bad back in 1990s, where we was losing about 7.8 million hectares a year of forests. That has slowed. We're now down to 4.7 million hectares, but that's still forest loss. That's a net forest loss of 4.7 million hectares. So that is less carbon being able to be taken out of the atmosphere across the globe, which isn't a good thing, because obviously we're emitting even more, and there's less forest and other natural resources to enabling that to be taken out in the atmosphere. Key culprits. This map unfortunately hasn't been updated for a few years, but this is still probably fairly current. The only change is probably Indonesia, the red on the far right, which has really turned itself around and is starting to really reduce its deforestation. But South America, Sub-Saharan Africa, and parts of the Far East are still in a state of sort of deforestation. So we do need to be really careful where we get our timber from, and make sure we ask questions around that certification to make sure it's responsibly sourced. So Brazil was losing over 500 million hectares. It's about 3.5 football pitches every minute at one point. It has slowed slightly, but we're still losing a lot. So we really need to be asking those questions. But just to look at what we buy, so these are the latest figures, the 2024 UK timber consumption. The 2025 figures won't be out until probably near September this year. So these are the latest figures that we have. And you can see that we consumed around 15 million cubic meters of timber in the UK. A vast majority of that was from softwood products. So that's, so that would be sawn timber or particle boards, OSBs, fibre boards, and MDF. All those are made out of that softwood product. Small amount of sawn hardwood, so just under 500,000 cubic meters there, and quite a bit of plywood, just over 1 million cubic meters of plywood, the majority of that is what we call a hardwood ply. And then a growing amount of engineered timber. So engineered timber is COT, glulam, and the big proportion of that is actually I-joists. So things like engineered timber joists is a big proportion of that engineered timber. Table form. So this is where your timber comes from. So that 5.8 million cubic meters coming from the UK. The vast majority, over half of our timber comes from the EU, so very responsibly sourced. But it's those areas, places like China, Brazil, where we're still getting timber from, which are seen as higher risk, and that's where we really need to be concentrating our efforts. So things like plywoods and stuff like that. And let's say it's not. We know there are some issues with certain places, but timber generally is a fantastic resource. It's renewable, and if it's managed in the right way, it's a good resource to use. So so make sure we're using sustainably managed forests. These are some examples from the UK and Malaysia there. And obviously that's all picked up in the government's timber procurement policy, where they require that sustainable timber, and they reference the three main schemes that we talked about earlier on. So PEFC, FSC, and Grown in Britain are the three certification schemes that the government recognises as being sourcing sustainably. So if you want more information on how that works, we have got some. There's another CPD on responsible sourcing, which goes into detail on chain of custody and stuff like that. So you can find a bit more information about on that. But when you look at actually where your timber is coming from, we talked about that most of our timber is coming from Europe. That PEFC area there, Europe is very strong on PEFC. It's only really the UK and Sweden that really focus on FSC timber. So if your timber's coming from Europe, it's more likely than not to be PEFC certified. Likewise, if you're getting stuff from the US or Canada, again, that's going to be PEFC. It's more the higher risk nations where FSC dominates. So South America, Sub-Saharan Africa, Far East is where they seem to dominate. So just bear that in mind. So obviously, moving on, as how do we assess that carbon? So we've now made sure our timber is sustainable. We can actually take that into account within our assessment methods. So basically what happens is when we look at a timber EPD, for example, it's split into a number of sections. So there's what we call the upfront stage. So A1 to 3 is the product stage, and A4 and 5 are the construction stage. So this is our upfront carbon emissions in effect. So raw material extraction, transporting the raw material to its production site, usually a sawmill, which would be the A3, the manufacturing bit. But there's bits in between that. So if you're remanufacturing, there'd be more transport involved and more production if you're making it into an engineered product, for example. Once you've got to that finished product, you're then transporting that to the construction site. And there's an element of carbon emissions to put that piece into place on that construction site. And that's what we call our upfront emissions. You've then got the use stage, so where you got either use of the product, is there any energy used for using it? Timber's obviously there isn't, because we don't have to plug it in, for example, so it wouldn't be any carbon emissions associated with that, for example, or emissions coming off of that product is more where B1 comes in. Maintenance, repair, refurbishment, replacement maybe comes into it when you're doing the whole life carbon assessment. So if you use a short life product, for example, if you're using an untreated softwood as a cladding on the side of the building, that won't last 60 years. So you're then required to show that that's going to have to be replaced in that 60-year cycle. So that would come into your assessment in that situation, for example. Then got obviously any energy on operational energy and water used by that piece of kit, which doesn't really apply to timber, as we said. And then you've got the end of life emissions, so demolition or deconstruction, transporting it off-site, and any processing. If it's a waste product, even if it's reused, there's going to be might need some processing or disposal. And that disposal is very much landfill, what we're talking about here, because if it's burnt for energy, that comes under that waste processing. It's classed as a recycled product and then goes into the energy sector as a product. And also within the EPD, you have to take account of the beyond the end of life cycle. Now, these figures don't form part of the overall impact of the product in the EPD, but they do show how that product could be reused at end of life. So, for example, is there a benefit of avoiding using, for example, recycled timber or in a panel board because you've got lower emissions in that situation from the virgin timber, because you're not having to fell a tree, you're only processing the recycled material. Or for example, if you're burning it, you haven't had to use virgin materials or maybe even another form of fuel. So there's those sorts of benefits that they take into account within that, but it doesn't form part of the main emissions in the EPD. As we mentioned, you've got embodied emissions are seen as those A1 to 5, B1 to 5, and C1 to 4. Operational emissions are the B6 and 7. And as we mentioned there, you've got that upfront emissions, which you might have heard of, called is your A1 to 5 emissions. So when you look at an EPD, this is a good example from Storians, although they have updated it, and it's not as good now, the latest one. This is the older one, but it's very clear, this one, so that's why I still use it. And what you're seeing there is you'll see a figure somewhere that talks about the biogenic carbon that's stored in the product. If there's a lot of packaging, over 5% of biogenic carbon in the packaging, then you need to report that separately. And timber very rarely, it does have timber packaging, but it's very rarely over that 5%. So you can see there the biogenic carbon of this particular product is 733 kilograms, so slightly lower than our average of 751. But what you can see underneath it is how that's made up. So you've got the fossil, the biogenic, and the land use and land use change or transformation figure. The key figure there for an impact is generally your fossil carbon. That's where your highest impact is going to be. And your biogenic carbon there, you'll see that sort of 7.33 to the power of plus 2. So that means it's 733 kilograms of biogenic carbon stored in that product. So that's how you read the EPD when you're reading it. And like I say, a lot of that's down to, where at A1, we talked about some of this earlier on. So your raw material extraction on average is around 12 kilograms. It's quite low. It's in that A1 section that you allow for that biogenic stored carbon. So in this example, the 733, you've then got transportation from the forest to the manufacturing plant. On average, that's around 17 kilograms per cubic meter. And then you've got the processing in the factory, which is around 6 kilograms of carbon. That's the bit that's reduced over the years because there's now a lot more biomass used. We used to, in a lot of cases, some companies had oil-fired kilns or gas-fired kilns, fossil carbon being burnt. Obviously, that would have been a much higher figure. They're near enough gone now. There's one or two maybe gas-fired kilns still around. But that's what's enabled that production to be really reduced compared with other materials like steel or concrete. You then transport to site. They're quite high emissions for some timbers, because a lot of this timber we're bringing in from Europe, for example, Scandinavia, Germany, Poland, depending on the material that you're talking about. So they can be quite high emissions per kilogram of material. But on site, fairly low emissions to put that into place. Generally less than 5 kilograms. It's a little bit difficult to get that data because that's coming out of the construction sites themselves. As far as in use, as long as you design the building to last that 60 years. So, for example, this example is, got cladding, that's brimstone, that will last 60 years. You shouldn't have any in-use emissions. But again, if you don't use a product that's going to last the life of the building, you might need to take account of some of that. And then end-of-life emissions are generally fairly small. So deconstruction, generally less than a kilo, less than 0.1 of a kilo in many cases. There's some transport off-site. So generally less than a couple of kilos to get it to a processing facility. And then C3, you've probably got you'll have the processing emissions in there, which can be high, 6 kilograms on average, but I think that's a bit higher. In a lot of cases, we're seeing that being a lot lower now. And that's where you would add back in. We talked about adding back in the sequestered carbon. That would go back in so that stored carbon can be transferred to the next product cycle. So, for example, if it's getting transferred from solid timber into chipboard, the chipboard can then take account of that 733 kilograms of carbon. That's why we do it, so it's transferred. Ideally, in the EPD, you should see figures for reuse, recycling, biomass, and landfill. Landfill is very unlikely. You very much don't see that. A lot of EPDs, though, they will take a mix, and it will be based on the country of production. So, if you're looking at an EPD from Germany, the figures for C1 to C4 are unlikely to be representative of the UK. So, can't really take that into account. So it's much better. We are actually looking to see if we can include some C1 to C4 figures for the UK going forward. So they should be in the latest data. We're just running that past our verifiers at the moment to make sure they're happy with that. So yeah, just bear that in mind. Don't use the EPD figures C1 to C4. And then, like I say, we looked at that beyond carbon ash. What are we talking about there? Well, timbers actually can be. It's a renewable resource in the first place. But we could do a lot more. We could reuse those elements that come out of a building. That's the first thing. Let's reclaim them, reuse them. We might need to take a few bits off of them, but we can generally reuse those elements. We can then recycle it into things like panel boards, also insulation, even MDF. Now there's a factory just opening in Wales which is recycling MDF, taking the glue out, and the fibre that's left is going in as a loose blown insulation into a closed panel timber frame. And as a last resort, we should be looking at using that timber for the energy production. So that should be a last resort. At the moment, unfortunately, all too often that's seen as the first line of defence, and we're burning too much timber at the moment. Probably about 2/3 of the timber that goes to waste is actually going straight for energy recovery, and we need to change that over the years. So in building, we've talked about the carbon for an EPD. In buildings, the process is exactly the same. We've got the same processes there: the upfront carbon, the A1 to A3. We just put all of those elements for all the different elements from the EPD into that whole life carbon assessment for the building, and obviously with the quantities of that particular material. This is the slide. This one here is I'd refer this to. So if I stop sharing that, sorry if that's coming up. So when you carry out a whole life carbon assessment, so that's A1 to 5, B1 to 7, C1 to 4, and D of a building, then you can include the in effect that negative figure that you'd usually get with timber in A1. So you'd be able to include that whole figure in there, which includes let's say a 751 plus the fossil carbon. So it'd be lower than 751. It'd probably be around 700 minus 700, something like that for a piece of softwood. Because you're adding back in that 751 at stage 3, so they balance themselves out. When you're doing an upfront assessment, you're not allowed to include that total figure. So you're not allowed to include the biogenic carbon in A1. So what you have to do is you state the in effect just the figure excluding the biogenic carbon element, and I'll show you some figures for that in a minute. And then you state that biogenic carbon, stored carbon in effect, you state that separately. Like we said, just a reminder, all timber must be from a sustainable source to be able to do that. So we'll just give you some examples here. So this is the TDUK weighted average data. If you haven't seen this, when you get these slides, you can click on, there's a hyperlink to it in the on the paper there. Just click on that and that will take you to it. But if you can't wait for that, just go to the TDUK website and head for the EPD database and you'll find it there. That's why we have 3 different figures here. So we have a figure here, which is the stored carbon. So this is for the UK, for example, stored carbon figure here. The figure excluding biogenic carbon, so in effect your fossil and LULUCF emissions here, and then the total A1 to A3, including your biogenic carbon. So you can see there that in effect, that figure is the sum of the figure excluding the biogenic carbon and the biogenic carbon in most cases. You also see there's an A4 emissions figure here, which is your transport from that factory to a nominal place in the UK. And what you'll see is there'll be figures for the UK, an imported weighted average, and then a UK import weighted average, i.e. in effect a consumption average. So if you don't know where your timber is coming from, you'd use the figure on the far right. If you know it's imported, you'd use the middle one. If you know it's UK, you'd use the one on the left-hand side. So, and like I say, you'd use then the figures. So if you was doing an upfront assessment only, you'd state the stored carbon separately. So for the UK consumption average, you'd state the 75 minus 751, and you'd only use the 69 in the calculation. If you're doing the whole life assessment, you'd include 682, and then you'd add back in the 751 at the end. Okay, hopefully that's clear. That's how the RICS professional statement says you must do it. As far as those assessments, as we said, exactly the same A1 to A2, A3. You generally see an A1 to A3 figure in a lot of EPDs, so you'd get that. Like we said, you'd use that minus 682 if you're doing a whole life, and you'd use the separate figures when you're doing an upfront. Your transport site on average is around 44, and you'd have to measure your A5 emissions, which, like we said, are probably circa around 5 kilograms of CO2 per cubic meter. But that's really something you need to measure on site with your contractor. In use stage, as we said, you shouldn't have any in use if you design the timber to last the 60-year life of the building. And on deconstruction, you're better off using like I say, we'll be better off using the TDUK figures, which we're just working on now, and we'll be able to update these for you at some point, which will be based on the UK average mix, which is those figures there. So at the moment, the latest figures we have for the UK is around 67% of our waste timber goes for biomass energy production, about 24% goes into panel boards, 8% into animal bedding, and less than 1% goes to landfill. So there's actually, all those are slightly over that percentage, and it's about 0.8% goes to landfill. So we don't need to worry too much about that at the moment. If you want to go into a bit more detail, we have got some papers in TDUK which give you a bit more of a split based on the product if you want to use that. So timber and the circular economy, how can we reduce that amount of carbon in the building? So how can we do something like that? So circular economy is the best way to look at that. How can we sort of maintain the building, make sure that its products are reused, remanufactured, redistributed, cascading recycling? So you may have seen this map. This is what we call the butterfly diagram from the Ellen MacArthur Foundation, which explains it. And the whole point is to try and keep your product within these inner circles as best as possible and avoid leakage into energy recovery and landfill. Possible construction circular model might look like this. So we've got our raw materials coming in. We want to try and avoid those fossil-based materials like plastics and stuff like that wherever possible. We want to look at our production and turn that into renewable energy use. We need to look at our business models. Construction is very much, for buildings, has very much been on a sale model. So you pay for all the materials, but could we start looking at lease models for the actual products within the building in the same way that we hire plant to build the construction site in the first place? We don't buy a piece of plant generally, use it to build the building and then throw it away. We generally hire it and reuse it in a number of different places. We could do that with materials. Obviously, we've got installation. Any waste from those processes should feed back into the system. And then we need to make sure that the installed product is used correctly, maintained to keep it in use for as long as possible. And only when it comes to the end of its useful life, it's disassembled, preferably for reuse somewhere else, remanufacture, or reuse the individual components, recycling them to reduce that need on more raw materials. And if we can't reuse that material in the production cycle, make sure there is a defined use for that elsewhere. And like I say, timber is fairly circular anyway. We mentioned this earlier on. We got the figures here that less than 1% goes to landfill. We do need to reduce that amount going into biomass. But what we don't know about is what's being reused and remanufactured at the moment. So we do need to have a little look at that. And we can, if you want more information on timber and the circular economy, we do have another CPD on that. But what we should be looking at is redesigning for reduced carbon. So do you actually need a new building? Could we make sure we assess that embodied carbon early to maximise the reduction opportunities, optimise the building form and layout to simplify the design, incorporate then the circular economy thinking to ensure maximum reuse of products and reusing existing materials from other construction sites, maybe on your product in your building. Review the embodied carbon of different structural solutions. So would timber work better than steel in a lot of cases? Consider the benefits of carbon storage within the building. Obviously, that's a big benefit, even though it's not highlighted necessarily in some of the assessments, but that's a big benefit because it's keeping carbon out of the atmosphere. And then look at your hotspots and don't forget about reducing the waste. So I've got a few examples here of things you might be able to do. This is the Aleander HQ in the Netherlands, 23,000 square meter workplace and workshops with storage, built in the 70s, early 80s. Concrete the client said they wanted to demolish this and start again. But the architect went in and said, no, I think we can reuse a lot of these components to reduce carbon, build more of a circular economy. So they re-insulated all those existing concrete buildings, put a new, in effect, skin on the outside, which was insulated and with timber. This was the artist's impression that they gave the client on the inside, what it would look like using pallets on the inside. Obviously, they're not subject to the weathering. They're durable timber on the outside cladding. And this is actually, and this is the final building. So this is, that's the completed building. And those timber bits you can see jutting out from the atrium there are those concrete buildings that have been reclad in a durable timber. Another example of building on top is a techniques building. The original building, if you look at this elevation here, that cornice line there was the original building. So there's another 3 stories being added on top of this building using timber with no impact or very little impact on the foundations required. So there was no underpinning or anything like that required on this building. Because the lightweight timber structure, the existing structure could hold that lightweight timber frame. We need to look at things like designing for optimal service life. So, like I say, using durable timber species on the outside of buildings. Where you are using on the inside of buildings, make sure use things like chemically treated timber. Don't to prevent against insect attack. Just be careful there that that some chemical treatments could limit future reuse, but that's just something we'll have to. Um, uh, Unfortunately, there's no alternatives for some of that at the moment. For the external building, though, you can use things like thermally modified timber. So this is a timber that's been modified by adding heat and steam, which changes a non-durable timber into something that will last a lot longer. And I think they're testing that to 50 years plus at the moment within the brimstone product, for example, or chemically modified. So this is in effect a coir is an example of that, where it's actually in effect pickled. They use acetic acid, which is in effect a vinegar, industrial vinegar to pickle the timber. So all of those will make that timber last longer in external environments if that's where you need to look at it. But also look at designing for optimum service life, and not necessarily maybe designers around the table, but contractors. Look at your hoardings. Could you use a reusable hoarding system like Hoardit rather than putting a new hoarding up on every site? These are reusable panels. They're still plywood. They're just a good grade of plywood that's had all the edges sealed and everything else, and you don't fix those. They're clamped into place so there's no holes for the moisture to get into. So that's something you can use, or reusable pallets. The loop system that's around at the moment that British Gypsum and others are using, which means they're returnable pallets rather than single use. Design freeze and maintenance. Do you have to finish the building? This is going back to that brimstone cladding in the previous photo there. This is a cladding system, thermally modified cladding. You don't need to coat. It doesn't need a coating, and it will silver off to this silver grey finish after around 12 months. And that will last, like I say, for 50, 60 years without any treatments. You don't have to then put someone up there to maintain the building, which is additional carbon impacts. Make sure we design these buildings for flexibility, deconstruction, and disassembly. Something that we're doing with my TDUK hat on. We're doing a paper at the moment to try and highlight the flexible connections that are out there for, things like Sherpa have these glue lamp connections that will lift on and off. So you can actually take the building, dismantle the building, but also internal flooring system. Cars have their Woodlock 5S system where you just pull a piece of plastic out and that whole timber element can be picked up and replaced somewhere else. And that's been done. This is an example of the Vitsu factory where these elements here, all these beams, for example, can be taken in and out, and they can add additional floor areas, storage areas, or if it's a high bay workshop or storage area, and they're just on those Sherpa connections that we mentioned earlier on. And the ABBA arena, if you've seen the ABBA show in London, that whole building that you was in is demountable and can be put into 20-foot shipping containers and shipped anywhere around the world. So lots of examples. This one was Östermalm in Sweden. Was a temporary market hall. They was refurbishing the market hall in this town, put up this temporary building to house the storeholders for about 18 months. And then that was taken down and that was shipped 500 kilometers southwest and was converted into a sports hall. So, so there's those sorts of things that we need to be thinking about. So just to finish off, we're just going to go on a couple of other bits of information. As I said, if you've got any questions on the end of this, please put them in the chat. I haven't seen any come up at the moment, so we'll have about 5 minutes for questions at the end. But just to go through a few bits that the timber industry is doing. So the net zero roadmap. This was launched in January 2023 for the timber industry and outlines how the timber industry will reach net zero by 2050. And it shows all the different elements of the timber industry, key ones being the top half here. This red line is the biomass industry and a lot of stuff that's imported for Drax, for example, which we're not necessarily involved in. But it's these elements here, the softwood and the hardwood and the waste elements that feed into the system. And what that's shown is that a lot of the emissions in the industry were down to the transport and emissions within embodied emissions within the product imported into the UK. And then we've got our own UK panel mill emissions, sawmill emissions, etc. down here. And those industries have been doing quite a bit of work to try and reduce that. This is the trajectory that we're aiming for. So we want to see Our transport emissions is a key one. This dark green here is the key one we want. Obviously, these emissions here are just as important, trying to see how we can reduce our emissions. And there's basically I won't read all of these out, but there's basically a 10-point plan on how the UK timber industry is going to reduce its emissions. And just a little example of this. This has just been released last week. So you'll be able to click on this and go to the link here. This is just been released is the UK's new C16 softwood EPD. So this is demonstrates how the UK timber industry has been reducing its emissions. It's a joint EPD from BSW, Glennon Brothers, and James Jones, which are the three of the biggest sawmills in the UK. All of those have just have PEFC certification, so dual FSC PEFC certification in a lot of cases. And what they've managed to do is over the last few years, since their last EPD, which came out in 2017, they've reduced their embodied emissions, excluding biogenic carbon, from 107 kilograms down to around 38 kilograms. And that's been achieved through a number of different measures, things like phasing out of those oil and gas-fired kilns that we mentioned earlier on and replacing them with biomass combined heat and power units. That then, they've also improved their transport efficiency. Some of them are looking at electric trucks to move stuff between plants at the moment, and they're trialing those at the moment. You've got reductions on-site energy use, and also those renewable energy generation. So in addition to the CHP, some of those factories are using renewable generated power from one of them uses power from a wind farm next door, for example, and heat from other another one uses heat from some processes as well. So so there's lots of things that they're trying to do to reduce those emissions, and we're obviously seeing some success in that. If you want more information about how timber and carbon are assessed, there's a couple of documents here from TDUK. The orange one here is a detailed document, goes into a lot of detail. If you just want the pricey version, go for the timber and embodied carbon knowledge sheet. Basically similar information, but just in a little bit less detail. But if you do need the detail, go to the orange one. So that's really it for today. Like I say, if you've got any questions, let's like to hear from you. You're quite welcome to put some questions in chat and we'll answer them. But as a call to action, hopefully you've now got a better understanding of how you can use timber to reduce the whole life carbon emissions of your projects. And just take a few takeaways from this. Assess that embodied carbon early to maximise your reduction opportunities. That's key. Look at the start of building a concept design stage. We should be doing whole life carbon assessments. And use the TDUK data, for example, to use for the timber elements, and there's other data out there for other elements. See what is the lowest carbon option for your particularly your frame. Is where you're going to make a lot of your carbon savings if you can change that frame from a concrete or steel to timber. Obviously, make sure that any timber that you do use is responsibly sourced, so you can take account of that sequestered carbon within the calculations for your whole life assessment. Use that information on the EPD for the product to be used, where you know what product you're using, and if you don't and you just know you're going to be using softwood or CLT, then initially you can use those TDK weighted average data where you don't know that source, and a lot of the tools already have that embedded in. So things like the Future Homes Hub tool, the Field and Clegg Bradley Studios tool, One Click LCA, all use that TDUK data for timber. So that's already embedded into their tools. If you're using one of them, it will already be in there. But if not, you're using your own tools, make sure you use that TDUK data. And then make sure you incorporate those circular economy design principles to reduce your carbon impact. So make sure that's included. That's all from me at the moment. Don't worry too much about the forms. I think you'll get a question when you close down. You'll be asked to complete some feedback. It only takes a couple of seconds, so please can you feedback for us? That would be great. And we'll open the floor to any questions. We've got 5 minutes left. Are there any questions from anyone? So just type them in the chat if you've got any questions. I haven't seen any at the moment. No questions. Okay, sure. There's no questions. Okay, well, if there's no other questions, thank you very much for your time today. Really appreciate you coming along today. Um, I've just got one in the Q&A. So great presentation. If you're applying a paint or treatment, how does this affect your EPD? Well, thanks, Lucy. If you're applying a paint or finish to that piece of timber, what you will need to do is obtain the EPD for that particular finish because they're all different. We can't sort of say there's a finish on the timber. So if you look at the EPD, it will generally say what the impact is of that paint for painting on a particular surface. So if you're doing a paint build up on say a timber frame window, for example, you look for the EPD for that particular paint supplier and add that in. To be fair, it will be quite a small impact. The paint supply generally is not a massive impact because it's such a thin coat of material, but there will be an impact. So it is something you should be considering, especially if you've got a big area that you're painting. If you, for example, if you're treating a cladding, for example, there might be quite an impact in some of those treatments depending on the one that you're getting. What are another one from anonymous here? What are the current barriers to increased use of homegrown engineered wood product? The key barrier there is the manufacturers. There are a couple of manufacturers that make homegrown engineered wood products. The key ones are God, I can't remember the name of the company now. There's a company down in the southwest that manufactures glulam from hardwoods. There's a company there that's manufacturing that. There's a company up in Scotland that's looking to start doing glulam and CLT, but on a small scale. But the biggest manufacturers are your people like James Jones and Metzer, which manufacture your engineered joists. So about 50%, over 50%, I think, of the engineered joists that are used in UK construction are actually made in the UK. Some of them will use imported timber in those, but the actual product is manufactured in the UK. Just on Lucy, and really end of life scenarios, how to use the timber afterwards. So, for end of life scenarios, if we're designing that timber to come out of the building, so particularly structural elements I'm talking about here. So, can we, for example, on glulam, use things like those Sherpa connections so that the timber can be lifted out? And if we're using a fairly standard grid size, that whole building could be dismantled and maybe put up somewhere else. That's the ideal. That's what we should be aiming for as the gold standard reuse, I think. But for any piece of timber, if we can design it so we've got maybe less treatments or less fixings in it, or where we are using fixings, make sure those fixings are removable or demountable, then there's more chance of that timber being able to be reused at end of life. So it's really a hierarchy there. And like I say, keep an eye out for a TDUK paper that we're looking to issue over the next few weeks, which details some of these, particularly for engineered timber products, some different connection types which will enable that reuse. Okay, I think that's all the questions. Hold on. So where are we? Do you think, last one from Alex here, do you think we're on track for meeting the carbon reduction standards by 2030 to 2050 with the current state of the industry? Very difficult one. I think it is possible, but we do really need to ramp up our emission reduction measures. And I mean really ramp up now. We've been sitting on our laurels for too long. We've really only got 25 years left to hit those net zero targets. We really need to be doing a lot of work now. It can be done. Like I say, I think there's a lot of work going on in different parts of the industry to try and reduce emissions. I think that the problem is going to be, people are thinking, oh well, we can offset. We'll just sit back and we'll offset our emissions later on. There will not be enough offsets available, and those offsets will be ridiculously expensive because by 2050 there will be in high demand. So, for me, look at low carbon options first. and obviously me being a timber person, that's a low carbon option. But there's others out there. There are bamboo, there's hemp, there's other natural fiber products that we should be looking to use, and only use things like concrete and steel where we really have to. So yes, we will reuse steel for timber connections, for example. We're probably still going to need to use concrete for foundations unless we reuse the existing buildings. Again, we need to be looking at more reuse of existing buildings and not demolishing buildings and putting up new. Let's re-engineer those those existing concrete buildings that we've got, probably using timber to make them higher, giving us more floor area, etc. That's where I think we need to concentrate our efforts. Okay, well, I think we're going to have to end it there. We're just over 2 o'clock now. Again, thanks for your time. If you need any more information on anything, my contact details will be on the slides. You can contact me at those details. And if you need any more information on PEFC, you can contact John at PEFC. So thanks very much for your time. I'll let you all go now. We'll end that. And just like I say, don't forget to answer the few questions at the end when we close down. Thanks again, and we'll get your CPD certificates out to you early part of next week. Thank you very much.